Ladies and gentlemen, then, today your task is to work with Newton's second law and demonstrating the impact that mass and force have on the acceleration. Remember that Newton's second law gives us the relationship that acceleration equals force divided by mass, or alternatively, rearranging the equation, we have force equals mass times acceleration. The materials you'll need for this activity begin with some tape, some index cards, a pulley, a blue plastic Hall's carriage cart, some string, a paper clip, a larger 200-gram mass, a smaller 100-gram mass, and a much smaller 50-gram mass. You will also need a balance and our GLX Explorer sensors equipped with a sonic ranger that measures the distance. So to set it up, one of the first things you're going to want to do is to attach the string to your cart so we can apply a force to it. And we can do that with the paper clip because on the cart, at one side, there is a hole in the center, and we can use this paper clip to create a hook by bending it out, and then we can hook that through the hole in the cart. Hopefully it's big enough for this. It's gotten a little small. There we go. And then we can attach the string at the other end by tying a knot around it. Before we go any further, we're going to need to know the mass of our cart. So we put the cart onto the balance to determine what is the mass of the cart. And you're going to want to record that in your data. This is the mass that the force is going to try to move. We could be more precise perhaps if we actually found the mass of our masses, but they are marked already. These are the masses that at the first part of our activity are going to be used to pull on the cart. The mass itself doesn't do any pulling. What pulls is gravity exerting a force on this mass. We call that force of gravity on a mass weight. Weight is a force. So we have to be able to calculate using that information and the acceleration of gravity, how many newtons that is. And so you need to follow that in your directions. Our sonic rangers also need a good target to bounce off those sound waves as it measures the distance and time. So that's where our card comes in. You're going to want to tape that card in whatever way you need to do to make that happen to the end of the cart using some tape. You want it to stick up nicely to create that target. Don't want that too big. And hopefully you'll be able to get that to stick up without interfering with the wheels. So now there's a surface that the sonic ranger's sound waves can bounce off of. So at this point we can put the balance to the side. We can take our pulley, and our pulley is going to need to go at the edge of the table where we can have some room to tighten that in. There we go. Our cart will go at the other edge of the table. There's our cart. Our sonic ranger is going to go behind the cart and will be plugged in. So it will take measurements as we've done before. And then you're going to run the string over the pulley So this should be at the exact opposite all the way across the end of the table. This will be over here. I'm going to cut that string off a little bit shorter. Not the best pair of scissors for this, but it will work. And then we have two choices. We can either tape or tie the string to the end of the mass. We're going to start with the smaller mass. And the weight of the smaller mass is going to be used to pull on the cart. So we're using the 50 grams weight to pull on it. This will hang down towards the floor. And when you are ready, you will then start your Sonic Ranger. Remember, it needs to be at least 15 centimeters away from it. And then you will release it and measure the velocity of the cart as it moves away from the Sonic Ranger. And you will look at those graphs of distance and time and velocity of time. Your task will then be to use the velocity time graph, find its slope. Remember, the slope, the rate of change on a velocity time graph, is acceleration. After you have completed the activity using the mass of 50 grams to pull on the cart, we're going to change things up a little bit. We're going to change the mass of the cart. And you can do that by adding a 100 gram mass into your cart and observe how that changes the acceleration, how it changes it or does not change it. And then you're going to repeat it again with a different mass. Instead of the 100 grams, you'll put the 200 gram mass into the cart. And again, set up with the Sonic Ranger, and you're ready to start it. And again, measure how that acceleration works with it. You're going to repeat every one of those measurements 2 times. So you'll have those measurements done with the various combinations of weight pulling on it and mass of the cart. The last part, you're going to choose 2 other options where you're going to choose a different combination of weight and mass to pull on the cart. As you're doing it, make sure you have someone keeping the cart from hitting the pulley and or running off onto the floor. Someone should be there to intercept it, to stop it from getting any damage. All right. Make sure then, before you go on each one, that you look at those graphs because you are expected to sketch them into your lab report. That is your basic introduction to what you will need to do to get this activity done. Those are the materials. This is how you set them up. Good luck.